Hello friends, in this lecture I will be explaining you the conditions for common root. As we all know that a quadratic equation has two roots. As it is an equation of degree 2, it has exactly two roots. If we are given two different quadratic equations, then the most common possibility is that both of them have different roots. But what happens if these two equations have something in common, that is either one of the roots of these two equations is common or both the roots are common. So we will try to find out a condition to get at least one root common or both roots common. So first we will discuss the case of both roots common. So if we are given two different equations, a1x square plus b1x plus c1 and a2x square plus b2x plus c2 is equal to 0, then if both the roots of these equations is common, then from the first equation we will assume that the roots are alpha beta for this equation as well as for this equation. So from first equation we get alpha plus beta is equal to minus b1 upon a1 and alpha into beta is equal to c1 upon a1. Second equation gives us alpha plus beta is equal to minus b2 by a2 and alpha beta is c2 by a2. So comparing the first two relations, we get minus b1 upon a1 is equal to minus b2 by a2, and comparing these two we get c1 by a1 is equal to c2 by a2. So if we cross multiply, we will get a1 by a2 is equal to b1 by b2 is equal to c1 by c2. That means if the corresponding coefficients of these two equations are proportional, that is a1 upon a2, the ratio of x square coefficient is equal to ratio of x coefficient is equal to ratio of constant term, then both the roots of these two equations will be same. This is the condition for both roots common. You must remember this. Now let's see condition for exactly one root common. Remember, this is only for exactly one root common. For both roots you have to go for the first case. So here we will assume that a1x square plus b1x plus c1 and a2x square plus b2x plus c2 both have one root common, that is alpha. Since alpha is a root, it must satisfy this equation, and also alpha is a root, it must satisfy this equation since alpha is root of both the equations. So on satisfying, we'll get a1 alpha square plus b1 alpha plus c1 equal to 0 and a2 alpha square plus b2 alpha plus c2 equal to 0. Remember, here alpha is a constant number which we need to calculate. So here you can use many methods: cross multiplication method, substitution method, or solving simultaneously. Basically you can consider alpha square as one variable and alpha as another variable, and two equations, two variables, and you can solve it. So if we use the method of cross multiplication, we get alpha square upon b1 c2 minus b2 c1 is equal to alpha upon a2 c1 minus a1 c2 is equal to 1 upon a1 b2 minus a2 b1. This is method of cross multiplication. From here we find the value of alpha using these two relations. Alpha is equal to a2 c1 minus a1 c2 upon a1 b2 minus a2 b1. From here we get, and if we equate these two, one alpha will get cancelled and you will get another relation. So since alpha is same, therefore we can say that minus b1 c2 minus b2 c1 upon a2 c1 minus a1 c2 should be equal to a2 c1 minus a1 c2 a1 b2 minus a2 b1. This, after equating this and cross multiplying, we get a relation a1 a2 c1 minus a1 c2 whole square is equal to b1 c2 minus b2 c1 into a1 b2 minus a2 b1. This is the condition for exactly one root common. I have represented this relation in determinant form so that you can easily remember. Remember, on the LHS here, whether you write a2 c1 or a1 c2, it doesn't matter because you are squaring it. once you take out the minus common, it's going to be squared and become positive. So A1C2 or A2C1. Now, there is a small trick to remember it. You write here AC AC, that is first and last term, then BC BC, then AB AB. Here in any order you can write, but you have to find all three possibilities: AC, BC, AB, and then you write 1 2 2 1 1 2 2 1 1 2 2 1. That is, you take minus common from here, it becomes A1C2 minus A2C1. So you write AC, that is first and last term, on the LHS, and the remaining two combinations BC and AB. Then you write the coefficients as 1 2 2 1 1 2 2 1 1 2 2 1. So this, there are different ways of remembering it. If you are good in remembering things, you can mug it up. Otherwise, you remember this trick. This condition is very important. There are quite a few number of questions already asked in IIT JEE on this concept. Now, if we need to find only the common root, that is, you have given two equations and you have to find only the common root. You don't need to find the condition or A, B, C, any other thing is asked. Just find the common root. What you do, you use elimination method. You multiply one equation by A2, the other equation by A1, and then subtract. Once you subtract, A1 A2 alpha square and A1 A2 alpha square will get cancelled, and you will straight away get alpha as A1 C2 minus A2 C1 upon B1 A2 minus A2 B1. You don't need to remember this. Multiply the first equation by A2, second by A1, subtract. This term will get cancelled, and you will be left with A2 B1 alpha plus A2 C1 minus A1 B2 alpha minus A1 C2. So you solve for alpha from these two and you will get the value of alpha. Now let's do a question. The question is, if equations 2x square plus kx minus 5 equal to 0 and x square minus 3x minus 4 is equal to 0 have one common root. If these two equations have one common root, then you have to find value of k. You pause the video, try the question. There could be two possible methods for solving this question. Method 1 is the longer one. First we will see, you apply the condition for common root. So for applying the condition for common root, you consider the first equation 2x square plus kx minus 5, a1 is equal to 2, b1 is equal to k, c1 is equal to minus 5. From here you get, and from here you get a2 is 1, b2 is minus 3, c2 is minus 4. Remember to take the signs. The general representation was ax square plus bx plus c. So if it is minus, you have to convert it, consider it x square plus minus 3 times x plus minus 4 times x. Minus 4 is equal to 0. So now if you apply the condition for common root, you will get a1 c2 minus a2 c1 whole square is equal to a1 b2 minus a2 b1 multiplied by b1 c2 minus b2 c1. You put all these values in this equation, solve, you will get a quadratic in k. 4k square plus 39k plus 81 is equal to 0. Use Sridharacharya formula or the quadratic formula and get the values of k. K is equal to minus 3 or minus 27 by 4. These two values are your answer. There is another method which is easy one. What we do here, since in these two equations which we are given, we see that this equation has one unknown variable k which we need to find, but this equation has no unknowns. This equation can be solved. So what we do, we solve this equation. On solving this, we get x is equal to 4 or x is equal to minus 1. Since it is given that one of these roots is the root of the other equation, so it must satisfy the other equation. So we put x is equal to 4 in the second equation and then solve. So if we put x is equal to 4, then we get 16 into 2 plus 4 into k minus 5. From here we get k is equal to minus 27 by 4. And if k is equal to minus 1, then if x is equal to minus 1, we put it, then we get 2 minus k minus 5 or k is equal to minus 3. So from both the methods we get the same answer. The first one is you have to remember a lot of formula, you have to remember the condition for common root and all that, and then apply it, and lots of calculations there. The second one is easier. For objective approaches you can go with this method. So this completes the topic of condition for common root. Thank you for watching. Please do subscribe to my channel YLC, that is your learning curve. Remember, practice makes someone perfect, and there is no substitute for hard work. Thank you very much.